Hello AP Chemistry. Although I'm not currently in class, I'm still going to give this presentation. One of you is going to be my hand in this class. Every time I say click the mouse and advance the presentation. Thank you. Anyway, I'm Eli Lee and this is my presentation about oleic acid, a chemical talked about in Chapter 14 of Napoleon's Buttons. Click. Okay, so what exactly is oleic acid? Oleic acid is a chemical that's found in high concentrations in olive oil. It's also used to make soap, usually from olive oil, and it was very widely traded throughout the ancient world. All of these things are important, and I'll get into that later. So, click. Okay. Olives were very important to ancient Greeks, Romans, and Egyptians, and this can be seen in the mythologies of these cultures. Essentially, the gods were given credit for giving olives to the people, and olives were holy as a result. The ancient Greeks had a myth that said that Athena had planted the olive tree that grows on the top of the Acropolis in Athens. And the Romans said that Hercules was the discoverer of the olive. Now, it makes sense that these cultures around the eastern Mediterranean were where the olive was first grown, and the techniques that they used to grow the olive tree were quickly spread around the ancient world because the olive is such a useful tree and a useful fruit as well. This is for many different reasons. Olive oil, first of all, is used as a food, as you all probably know. It's very high in calories and very nutritious as well, and I'll get into that later. Olive oil was also used as a fuel for lamps to provide light in the dark, which is pretty important as well. Olive oil was also used as a salve for the skin or to use as an ingredient for makeup for ancient women. And it was also known to have many medicinal properties. It was said that olive oil could help a man live to the age of 100. Okay, click. So obviously olives were incredibly important to the ancients for these many, many reasons. And it makes sense then that olives were protected not only by the laws of the state, but also by the laws of the religions. For example, you could be executed for over-harvesting your olive grove. And olives were present in the myths of these ancient cultures and also in the Bible, where they're mentioned over 100 times. Olives were a symbol of strength and peace, and we still see this kind of symbolism in modern times with the expression offering an olive branch to represent peace and making amends. A little less recently, the royals in ancient France were anointed with oil when they were given their crowns. Olive oil was also widely traded in ancient Greece, as I said before, and the importance of this will come later. Olive oil is generally transported in amphorae, which are these large earthenware vessels that you see. Okay, click. So what is olive oil, and what makes it olive oil? Well, in general, oils are liquids that contain lipids. And oils are generally extracted from plants. They're said to have plant origin. And olive oil was arguably the most important oil in antiquity for the reasons that I already stated. And what set olive oil apart from almond oil, say, was the presence of oleic acid. Okay, click. So all oils and fats are what are known as triglycerides, and this means that molecularly they're composed of 3 fatty acids linked to a glycerol molecule. And that's what you see in front of you on the slide. Click. Alright. Now this is another way to represent triglycerides, where a zigzag line is used to represent the long carbon chains. It's just easier to look at. Anyway, not all triglycerides are the same. Click. The circled portion here is the fatty acids, and those are what change. Click. What changes in these fatty acids is the saturation of the fatty acids themselves. And what this means is that they can be either saturated or unsaturated fatty acids. When they are saturated, then they have no double bonds, meaning that the maximum amount of hydrogen atoms surrounds the molecule. They are saturated with hydrogen. When double bonds are present, then they're unsaturated. When there's only one double bond, it's a monounsaturated fatty acid. When there's more than one, it's a polyunsaturated fatty acid. What you see on the right is saturated and unsaturated. And as you can see, the unsaturated fatty acid is bent. It's called having a kink in the chain, and that's because there's one double bond. So how is this relevant to olive oil? Click. So oleic acid is a type of fatty acid, and it is specifically a monounsaturated 18-carbon fatty acid, meaning that it's a fatty acid with an 18-carbon chain with one double bond. And the presence of oleic acid in the triglycerides of olive oil is what makes it olive oil. Oleic acid is present in many oils, but only olive oil has 55 to 85% oleic acid, and this is very, very significant. What you see on the bottom of the slide is a molecular structure diagram of oleic acid. Click. So oleic acid obviously makes olive oil taste and smell differently, but more importantly, it also prevents heart disease for two reasons. First of all, consuming oleic acid doesn't raise blood cholesterol. It increases the presence of good lipoproteins over bad lipoproteins in your blood, which prevents your arteries from clogging up and then prevents you from having a heart attack as a result. Oleic acid also increases the shelf life of olive oil. It makes it more stable and resistant to decomposition and spoiling, which was very, very useful in ancient times when there was no refrigeration. It's also important to note that oleic acid contains amounts of vitamins E and K, which are antioxidants which prevent aging, perhaps the basis for the claim of 100-year longevity as a result of consuming olive oil. Click. So oleic acid is also important because it fueled ancient commerce. Ships containing cargoes of olive oil crisscrossed the Mediterranean Sea in ancient times, fueling the rise of democracy by helping to promote cosmopolitanism in the Eastern Mediterranean. Later on, oleic acid was used to manufacture soap through the process of saponification, which you can see here. And that's when a triglyceride is broken up into glycerol and a soap molecule. Click. Soap molecules have a structure that consists of a long hydrocarbon chain and an ionic head almost. And the ionic head is hydrophilic, so it'll attract water, and the hydrocarbon repels water. Click. So what happens is that grease particles in water, when soap is added, are surrounded by these hydrocarbon chains, and then the water attracts the ionic heads, causing almost a surrounding effect of the grease particles, allowing them to be easily washed away. The exceptional qualities of oleic acid produced exceptional soap, which was able to be mass-produced and spread throughout the Western world in more recent times. This reduced infant mortality and allowed a higher degree of cleanliness to be achieved, something which is incredibly important and also incredibly relevant on a day-to-day scale. Click. So in conclusion, because of its many beneficial effects and the ability to make soap with it, not to mention the stimulation of trade in the Mediterranean, olive oil was incredibly important in ancient times and is still incredibly important today and in more recent times. In essence, it helped to establish our culture as we know it because of its importance in ancient Greece and Rome. Click. The end. Thank you.